So, as part of reactions in aqueous solution, there are two topics that fall under this: hard water and acid rain. So now, hard water caused a lot of humor the first time I taught it, so I hope you're not busy laughing behind my back about this, but hard water is actually quite a problem in quite a few places in South Africa. So we have to discuss it briefly here. And also acid rain. Acid rain is far worse problem in more industrialized countries, although it is also a problem anywhere there is any industry. So let's go have a look at these two topics. So what's hard water actually? If you've got water, now this is usually water that you get out of a borehole. If anybody lives in a place where they survive with only borehole water, you often find that it's hard water, and that's also why sometimes the water at the school tastes a bit weird, because some of the water at the school is coming out of a borehole and it's hard water. So the hard water contains a large amount of dissolved minerals, especially calcium ions and magnesium ions. So usually what happens is it's borehole water, the rain falls from the sky and it lands on certain kinds of rocks such as limestone and dolomite. And then as the rainwater lands on these rocks, it dissolves the calcium and magnesium ions in the limestone and dolomite, and then it gets stored underground with these ions in solution with it. Okay, so if the rain falls on different kinds of rocks, it can pick up sodium and chlorine ions like by the sea, and that would be soft water. But this calcium magnesium ion usually linked with carbonate ions as well. These are hard water. And how do you know if you've got hard water? Well, partly you can taste it, okay? But mostly there are two things. The one is your kettle will look like this. And the other one is when you try to bath yourself. The soap does not make lovely bubbles, and you have to use a lot of soap, and you go through a lot of soap. And if you actually bath, the soap makes this horrible scum around the side of the bath, your bath ring. Okay, and that's because these ions are reacting with the things in soap that clean you, and this precipitate causes a big problem because you're wasting your soap, it makes a mess and stuff like that. And you can also see hard water, like when the sprinklers hit the windows at school, you can see it leaves that white stuff on the window when it dries. That white stuff is this calcium and magnesium ions, usually with carbonate ions, and that's actually calcium carbonate dried on the window. So if you put hard water in a kettle, they will, and you boil it, the calcium and magnesium carbonate precipitate out, and basically they form lime. They're forming a rock on the element, and this is what destroys geysers and kettles and stuff like that. So this is calcium carbonate, and if you want to get rid of the calcium or the magnesium carbonate in your kettle, you have to dissolve it, usually with some kind of an acid. So people will tell you put vinegar in your kettle and boil your kettle with vinegar. You can also put pool acid in, provided you dilute it. If you don't dilute it, you're going to destroy your kettle. I know this from experience. So anything that's acidic will get rid of this. So lemon juice, vinegar, citric acid, anything like that will dissolve this in your kettle, because if you leave it in there, your kettle element will get too hot and will explode. So if you've live in a borehole area and you've got really bad hard water coming in and it's a nuisance, you can get one of these things that contains zeolite. It's an ion exchanger, and you need huge bags of salt. And so what happens is on the zeolite crystals, you pump in the hard water and a sodium chloride solution, and they mix over here, and then some of the water comes out, and then on the other side out comes the soft water, because you've got this to swap the calcium ions and the carbonate ions for sodium and chlorine ions. And then this is how you soften the water. But you keep having to replace the salt as you run water through this thing. So usually hard water is a nuisance and people need to soften it. But if you soften the water, sometimes it tastes a bit salty, and it's the sodium ions that are swapping out the ions mostly. So that's basically what's hard water. And then the other problem that happens with aqueous solution is acid rain. So this is an example. This is the same statue. The picture was taken, I think, 30 years apart, in just after the Industrial Revolution. So this was pre the Industrial Revolution in England somewhere, and this was after the Industrial Revolution. And in the Industrial Revolution, they made a lot of carbon dioxide and sulfur dioxide gas that went into the atmosphere, and it came back down as acid rain on this marble statue. And you can see she's basically lost all of her features as a result of the acid rain eating away the limestone. So what happens is non-metal oxides react with water in the atmosphere. So carbon dioxide and water forms carbonic acid. So this is also what's in your soda water, but it's happening in the sky in clouds, not in your soda water, but there's carbonic acid in your soda water. So sulfurous acid is sulfur dioxide, and water gives you sulfurous acid. And then nitrogen dioxide will give you nitrous and nitric acid, okay? So all of these acids, except for nitric acid, these three are weak acids. This is a strong acid. But even being a weak acid, they will eat away statues and anything made out of marble. And all of these come from burning fossil fuels. So if you burn coal, if you burn natural gas, stuff like that, there's always sulfates and nitrates mixed in with the carbon in the fossil fuels, and that's how you get acid rain. So what is the problem with acid rain? It eats away the paint on the buildings, it destroys statues, it costs money to fix it. If it's bad enough, it also damages plants and soil. So this is an evergreen forest somewhere, like I think up north by Russia there, and the acid rain is particularly bad there. And these are actually evergreen trees that have basically been killed by acid rain. So I mean, there's plants here that are alive, but many of them have been completely destroyed by acid rain. It also can go into ponds. And in grade 12, I've got a picture of acid rain with the fish, dead fish in a pool. That acid rain has made the pool so bad that it's killed all the fish. Basically, they can't survive in such an acidic environment. So everywhere that there's a lot of industry, and the industry is not monitored for sending out sulfur and nitrogen and too much carbon dioxide, you will get acid rain, and it will basically just destroy the environment. So it's a hazard.